All right, so today we're going to talk about infinite limits. So let's begin with an example here. So I want you to take a look at this limit. Go ahead and jot this one down. So we're going to determine if the limit as x approaches 2 of f of x, what is that limit if f of x is defined as 3 over x minus 2? So what is that limit defined as?
Pardon the interruption. Tatiana Guzman, please report to the front office. Thank you.
Okay, so when you're thinking about doing this limit, what are you thinking of? Can you simplify it in some sort of way? Can you direct substitute? So if you try to direct substitute, let's try that. So if you try to direct substitute, you get the limit as x approaches 2 of, let's say, 3 over x minus 2. That gives you 3 over 2 minus 2, which is 3 over 0, which is what? Well, not indeterminate, but undefined. All right, so that's undefined, correct? So that doesn't work. So go back to the drawing board. Can't do that. Can you manipulate this algebraically in some sort of way? If you multiply by something, it's just going to divide out, right? So the next thing you probably want to do is maybe, let me go back. Let's go back. You might want to use a table. So I have x, and then I have f of x, right? You guys remember when we did the little table? And what number are we approaching from both the left and right? What number are we getting closer to? 2. Remember, do we care what happens at 2? No, we don't. All right. So let's talk about this limit here. So if I have the limit as f of x, or excuse me, the limit as x approaches 2 from the left of f of x. So what are some values that are below 2 or smaller than 2? Like I could do roughly maybe 1.5. Sarah, you said 1.9, maybe like 1.99 as we get closer and closer to 2 from the left. All right, can we put that in our calculator really quickly? You guys have a calculator to evaluate this real fast? All right, so what are we going to get here for 1.5? What's our value going to take? Negative 6. What about 1.99? -30. -30? What about 1.999? Or excuse me, 1.99, excuse me. So -300. And it looks like it's getting really, really close to what? What does it seem like it's approaching here from the left? What kind of infinity? Negative infinity, right? So it's approaching negative infinity. All right, let's do it from the right. So from the right, maybe we can kind of do values that are kind of like mirroring, maybe like 2.01, 2.1, and 2.5, correct? What kind of values do you think you're going to get over here on the right side? So as what I'm saying here is, what is the limit as x approaching 2 from the right of f of x? What is that going to look like? Positive infinity. So what value am I going to get here for 2.5? For 2.1? 30. And then for 2.01? So this is approaching what? Positive infinity. So I have one limit as you approach from the left. So remember, this is from the left. That's approaching negative infinity. This one over here from the right is approaching what? So my question is, what's the limit? So therefore, the limit as x approaches 2 of f of x is equal to what? Does not exist, technically, right? Because you get a negative infinity, you get a positive infinity, et cetera, et cetera, et cetera. Now, if you guys remember what this graphically looks like, I was kind of alluding to this when we were checking over homework, right? What do you have going on at 2? You have a vertical asymptote because this is a rational function, correct? So you have some vertical asymptote there. And then your graph is going to roughly look like this, correct? So notice that on the left side, this is that going to negative infinity piece, right? And then from the right side, that's it's going up to positive infinity. You guys with me? That's why your limit doesn't exist, because you're not approaching the same value. Okay? Are you guys good with that one? So this limit does not exist, and that's going to kind of give us some conversation pieces for today. All right, so let's take a look at this definition here. So you need to make sure you jot down this definition. It says an infinite limit is a limit in which f of x increases or decreases, quote unquote, without bound as x approaches c. Now, there is an important note here to make that the limit as x approaches c of f of x equals infinity actually means that the limit fails to exist due to its unbounded behavior. We talked a little bit about this last week when we talked about unbounded behavior, about if a limit approaches from infinity or negative infinity, even if it's the same direction, that it technically doesn't exist, or it fails to exist, but it doesn't mean it doesn't exist. I know those are kind of confusing things. It fails to exist because it's not bounded. A lot of textbooks and a lot of people think that limits, or believe that limits, must be finite in value to exist. So sometimes you're going to see them listed as fails to exist, does not exist, even though technically it's not appropriate to call it does not exist. But as it approaches, I guess, the same value from the left and the right. So if both were approaching like positive infinity, it would be positive infinity, or I guess fails to exist because it's unbounded. But it doesn't exist unless it's like the last example we did where they approach both from the left and the right, but one goes to positive and the other goes to negative infinity. So just as a disclaimer there. But an infinite limit is a one in which f of x increases or decreases without bound as x approaches c. All right, let's take a look at this limit. So what if we had the limit as x approaches 1 of f of x, if f of x is equal to 1 over x minus 1 squared to both the left and the right. So what if we had this? All right. So let's go first from the left side. All right. So what if I had the limit as x approaches 1 to the left of f of x, right? So what would I get here? Can you do it in your head? It's either infinity or negative infinity, right? Do you guys remember what 1 over x squared looks like? What does 1 over x squared look like? It's when they converge to the same one. Look, this has been translated how much? To the right one. So I have this asymptote right there, and then it kind of looks like that. Correct? Okay. All right, so limit from the left. What is that going to be equal to here now that we have the graph here? Infinity, right? What about the limit from the right? That's going to be positive infinity. So again, you need to pick out whichever technique is going to be easiest in helping you evaluate a limit from the left and from the right. Here, graphically, knowing that 1 over x minus 1 squared is just going to be this kind of like rational function, but they both go the same way kind of deal. That's the easiest way to evaluate this. So therefore, what does that mean about the limit as x approaches 1 of f of x? What does that equal? Infinite. So infinity. But you could also say it fails to exist due to unbounded behavior. So it could be either or option choices. All right? Does that make sense with the either or option choices? I prefer you calling it infinity, but don't be surprised if it says fails to exist or does not exist for one of the options. I know on the AP exam, they're not going to give you both. So they're going to tell you it's infinity or they're going to tell you it doesn't exist. Does that make sense? All right. You guys good with that one? All right, so here we go with the vertical asymptotes idea. So we kind of did this with our first example, but this is going to be the formal definition of what a vertical asymptote is. So in calculus, if you have a limit as x approaches a from the left, f of x is equal to either plus or minus infinity, and the limit as x approaches a from the right of f of x, and that equals plus or minus infinity, that means that you're going to have a vertical asymptote at x equals a. All right, so that basically means this. So think about the first graph that you saw. So if I have an infinite discontinuity here, and let's say my graph looks like this, approaching from the left, and that approaching from the right. that means that you're going to have a vertical asymptote at that point. Notice here that the limit of this function, oh, I wrote that wrong. Let me go back and change that. The limit as x approaches whatever c from the left of f of x, notice that from the left means I'm going to be going towards positive infinity. And the limit as x approaches c from the right of f of x, I'm going to be going towards negative infinity. So notice that you either go towards positive or negative infinity. If that's true, coming from the left and from the right, okay, it doesn't matter if it's positive or negative. That means, therefore, x has a vertical asymptote at x equals c. Does that make sense? Okay, so that's just a formal definition of that. Right? All right, so for an example for this, so let's go ahead and find any vertical asymptotes and write them as limits for this function f of x, where I have f of x is equal to 1 over 2x plus 2. All right. So the first thing we want to do is we want to analyze the function. Anything I can do to factor here. Take out a GCF from the denominator. So that's 2 times x plus 1 on the denominator. You guys agree? And you guys probably remember this back from math pre-calculus. You guys already see that, correct? You guys see the vertical asymptote? What is your vertical asymptote here? X equals what? Negative 1. Do you guys see that? That's just whatever's on the denominator that doesn't divide out. Now, how do you write that as a limit? How do you write that as a limit? Because what would this graph technically look like? It's a rational function, right? Once I factor out this 2 from the denominator, how's it been moved? Left what? 1 unit. So that's where you told me my vertical asymptote is, x equals negative 1, right? So then what would this look like? It goes like this, right? You agree? Roughly. It's always first, third quadrants unless it's been reflected. So then it'd be second and fourth. All right, so what's happening with our limits? So what's my limit as x approaches, what do I have? I'm approaching negative 1 from the left of f of x. By definition, that has to either approach what? Infinity or negative infinity, correct? Which one is this approaching from the left? So from the left, I'm approaching negative infinity. And what's the limit doing as x approaches negative 1 from the right of f of x? This time it's going towards positive infinity, correct? And that's how you do it. Basically, in calculus lingo, we now know that x equals negative 1 is a vertical asymptote. Does that make sense?
So you write those limits to prove that it's a vertical asymptote?
It's just the way you write it in calculus. So in calculus, they're not going to tell you that x equals whatever is a vertical asymptote. They'll probably give it to you in limit notation. You just need to know how to decode it.
Okay.
Does it make sense? Like there's going to be oftentimes questions where they'll say, which of the following is a limit representation for a vertical asymptote? And you just need to know what that looks like. It says x approaches the value of the function and that approaches infinity or negative infinity. There's going to be a way to write horizontal ones and we'll learn that in a little bit. You guys good? Okay. All right, let's do this example. I'll give you a second to try this on your own. All right, let's go over this one. So what's the first thing that you need to do? Factor out difference of squares, right? So what's the difference of squares on the denominator? X minus 2, x what? What happens when I do this? When I divide out those common factors of x plus 2? That means that you're going to have a hole on your graph, correct? Does that make sense? And what's going to be left over? It's a rational function, 1 over x minus 2. All right, rough sketch. What does this look like? Where's your vertical asymptote going to be? Have you been reflected over the x-axis at all? Nope. So that means it's going to be first quadrant and third quadrant. Correct? Rough sketch. Okay, so let's write our vertical asymptotes as limits. Can anybody give me one of the two? Because you have to write 2.
As x approaches 2 from the left.
So the limit as x approaches 2 from the left of f of x, what's that going to be equal to, Mike? Negative infinity. And what's the other one? The limit as
X approaches 2 from the
of f of x. Therefore, there's a vertical asymptote at.
X.
Does that make sense? Okay.
So if you're boxing your answer, then what would you?
Like, I would say, like, if it asks you to write its limits, that's your answer right there. Okay. Do you guys know where your hole is at, by any chance? Well, it is. What's the y value?
Very.
Negative 1/4. Which group?
Mhm.
It'd be 0.
But it's a 2. Yeah, it is. I thought it was like
Well, can't touch
Oh, yeah, it is negative 2. Oops. You're all right. It's negative 2. So where would that be?
No, it would be
So what's up with negative 2? 1 over negative 2 minus 2, which is negative
Yeah, so
1/4.
I'm sorry.
Yeah, so how does it go down to the
yeah,
right?
we asked for the whole list. No, I'm gonna.
How does it go down to the right on the left side? Negative 2 is negative 1/4, but 1 is just 1.
So like 0 there, it gets negative 1/2 because like the values here are getting actually like bigger, but they're negative. Does that make sense? Like you're gonna have a hole like right there. So to speak.
No, 1 goes to negative 1.
So like if you were to do the y-intercept, like it's at negative 1/2. Like this is at negative 1/2. This is at negative 1/4. And if you keep putting numbers there, you're gonna keep getting like
I just messed
small, like smaller and smaller and smaller numbers, because remember you're approaching 2. So like if you plug in 1, that's going to be negative 1. So that means it's going to keep going like down this way. Like I'm just plugging in numbers to the expression here. All right, you guys ready to do another one? Cool. All right, what about this one? Let's do this one together. This graph, you're not going to really know off the top of your head what it looks like, but you can still find the vertical asymptotes in the holes of this function. And then we'll take a look on Desmos really quickly about what this graph actually looks like. All right. What's the first thing that I should probably do?
Factor of 2
Where?
on the top.
On the numerator, I have a 2 over x minus 4, or 2 times x minus 4 over an x minus 4 times n, x minus 3 times n, x minus 2, correct? If I divide out my x minus 4s, remember when you divide out factors, that implies that you're going to have a hole. So I have a hole at that x equals 4 value. Back from math 3. So this would be 2 over x minus 3, x minus 2. Where are my vertical asymptotes going to be at? At 3 and 2. Well, x equals 2. X equals 3. So what if I were to write these as limits? Probably need to take a look at the graph in order to be able to see the direction, correct? All right, so let's take a look at what this looks like. So I'm going to click this button real fast after I do the arrow thing. So I already preloaded a graph here on Desmos. And this is actually what your graph looks like. Okay, so I typed this in really quickly. So 2x minus 8 over x minus 4, x minus 3, x minus 2. Is that correct? So notice it kind of has those like rational branches that are coming over here from the left and from the right. But what does it seem to have in the middle there?
Upside down graph.
Kind of looks like I have like a parabolic function there. And that's kind of bounded between what 2 asymptotes that we saw? 2 and 3, right? So this parabola is going to be pretty skinny. It's going to be bounded there between 2 and 3. So the idea is like you don't actually need to know what this graph looks like in your head. You just need to be able to analyze it and tell me where the vertical asymptotes, where the holes are. Does that make sense? Let the graphing calculator kind of give you that information. Does that make sense? All right, so let's go back to our PowerPoint. Oops, yeah. Oh, did I write on the wrong one? I was on this one, right? Oh, okay, cool, came back. All right, so let's sketch what we have there. So it should be like this, and then I have something like this. And then over here at 4, do you guys see here at 4? That's going to be part of this like right branch, correct? Well, where's that hole going to occur at? How can I figure out where that is? I need to plug that into my simplified expression, right? So I need to do 2 over 4 minus 3 and 2 over 4 minus 2. You guys see that? So where is that y value? So that's going to be 2 over 1 times 2, which is 1. So you guys okay with my hole being at 4, 1? So over here at 4, so that's at 2, this is at 3, so 4 at 1, I guess somewhere around there, I'm going to have a hole, but then I'm going to have this branch kind of connected. You guys with me there? Okay, so this is just a little bit of review there. Okay, so I think we're now able to start writing limits, correct? So let's write a limit for x equals 2. So what's x equals 2? So as the limit of f of x approaches 2 from the left, which infinity am I going to? Positive or negative? I'm going to positive. The limit as x approaches 2 from the right of f of x, what is that approaching? Negative infinity. You guys there with me? So I was talking about like approaching 2 from the left, going to infinity. So this is 2 from the left. And then from the right, notice that's negative infinity for 2 from the right. You guys see that? Yes? The other one, as I go from 3 to the left, where does it seem like I'm going? So that's going to be, so 3 from the left seems to be going towards what? But 3 from the right seems to be going to positive. So basically kind of almost switched. Negative. All right, and that was basically that first one. Good? Questions? All right, do you guys need me to keep that up there a second? All right, so here are some properties of infinite limits that we need to discuss. So go ahead and take a second to copy these down, and then we'll discuss them in a moment. All right, so go ahead and jot down 1, 2, and 3, and then we'll discuss them through as a minute. So go ahead and pause and do that real fast. All right. So with these limits, so notice here that f of x as x approaches c goes to infinity, but g of x as x approaches c goes to some constant L, so it goes to a number. So f of x is approaching infinity, g of x is approaching some number L as both x goes to c for each of those, right? So right here, if you add the two limits, and we did these kind of limit laws earlier within the unit, correct? So if you have a limit as x approaches c of f of x plus or minus g of x, that's still going to give you infinity plus or minus a number. Infinity plus or minus number is still what? Infinity. So infinity trumps if it's just a number, okay? With multiplying, notice there's 3 cases. If L is positive, you guys understand that if it says L is greater than 0, this means positive numbers? Yes?
Yes.
What about this one?
Negative numbers.
And then if L is 0, well, obviously 0. Okay, so if you have infinity times a number, okay, if that number is positive, it's infinity. If that number is negative, it makes it negative infinity. If that number is 0, it makes it 0. Because anything times 0 is what? 0. Does that make sense? All right, so that's some limit laws there. Now, the ones that we use the most when we're talking about infinite limits are going to be number 3. We often will use number 3 the most. Notice here that if g of x is approaching a number and f of x is approaching infinity, a number over infinity is what? 0. Does that make sense? Because, no, the x is not 0. The x is approaching c, some random value c, right? But if you have L over infinity, some number L, so some number over infinity, you're approaching 0. And I want you to think about it like this. Think about like fractions, okay? Like 1 over 2. You guys see that? Compare that to 1 over 20. This is 0.5 and this is 0.05. And compare that to 1 over 200, which is 0.005. Do you guys see that? What numbers are these decimals approaching?
0.
As the denominators get bigger. So as your denominator gets bigger and your number on the top stays the same, notice you're approaching what number? 0. So if the bottom is growing faster than the top, it's approaching 0. However, if you have it the other way, where g of x is on top and f of x is on the bottom, actually that's an error. Can you guys fix that for me? What should this be? That should be f of x over g of x. Can you guys change that in your notes? I made a typo. Oopsie.
That's wrong.
Oopsie. That happens. I'm sorry. You want a hug? No? Okay. I'm sorry for my error. Anyways, it's infinity over L. And infinity over a number that's non-zero is what? Infinity. Notice that L cannot be 0 there. I made a typo. I apologize. You forgive me?
No.
Okay. Thanks, Colin. Yes. Very similar to the other one. All right. Now, in behavior, I want you to go ahead and write this down as I'm speaking. In behavior, limits are really easy. You guys think that these are the easiest limits in the entire universe because basically you're going to think of this as like a race. What's growing faster? The numerator or the denominator? If the numerator grows faster, it's going to approach infinity. If the denominator is growing faster, it's going to approach 0. Okay? Seniors, you guys can go. The only issue is when they're actually growing at the same rate. And we're going to talk about that. Okay? So I think about this as like racing cars. Like what's racing faster? You guys ever watch NASCAR?
Yeah. NASCAR on NASCAR.
NASCAR is NASCAR. All right. So when we talk about the in behavior as limits approach infinity, it's going to be basically which one's growing faster. Does that make sense? Okay. So make sure you jot that down. All right. So it's NASCAR time. Are you guys ready for this? Ask yourself in example 1, as the limit, as x approaches infinity, does e to the x grow faster or does x grow faster? So e to the x grows faster. So this is going to be infinity because e to the x grows faster than x. So e to the x grows faster than x. All right, number 2, what's growing faster? X or e to the x? We just talked about it, but where is e to the x? It's on the denominator. So if the denominator is growing faster than the numerator, this or limit's approaching what? 0. You did. Yep. All right, what about the limit as x approaches infinity of 1 over x? What's growing faster? The constant 1 or the variable x?
X1. Easy.
It's not really, it's 0. Because x goes to infinity faster than 1. Because 1 is just 1. Colin, stop. Number 4, what's growing faster? The numerator or the denominator? Okay, so here when you have multiple variables, this is a technique that you'll see other people use. You identify the highest power. So what is the highest power? X to the what? Third. You guys agree that the highest degree, the highest power is x to the third. You'll see some textbooks and some people do the limit as x approaches infinity of 2 over x cubed plus 5 over x cubed all over 3x squared over x cubed plus 1 over x cubed. So you'll see people divide each term by x cubed, right? Does that make sense?
No, it's still be 0, correct?
Okay. Well, hold on. Let's get there, right?
Okay.
Okay. So let's still get there. Is it x squared or x cubed? I think it might be x squared by the lowest power. Anyways, you'll see people do it like this. I think it actually might be the lowest power. That's here. Anyways, this is how, okay, so you'll see people do that. I don't do it that way, which is obviously why I'm like, I don't know if it's highest or lowest. So let me show you this other way. Do you guys see, let me erase this too. As you're going to infinity, do you guys see that 5 and 1 don't really matter? You guys okay with that? When you're talking about you have $1 billion, you're going to remember you had $1 and $5? Not really, okay? Because you're going to have so much money you don't know anything. All right, so then you're left with 2x cubed over 3x squared. You guys see that? So then, what's this going to be? The limit, as x approaches infinity, of 2x over 3. Because here, if you subtract those exponents, right, you're left with just this. You guys see that? Now, which one's growing faster at this point? The numerator or the denominator? And it's growing towards what? Infinity. All right, it's growing towards infinity then. All right, number 5, when you have the limit as x approaches infinity of 4x squared minus 3 over 2x squared plus 1. Again, as you're going to infinity, what's happening with this -3 and this 1? Doesn't matter, right? They don't matter in the long run. So here I have the limit as x approaches infinity of what? 4x squared over 2x squared. Do you guys see what's happening here with these x squareds? They divide. So now it's just going to be the ratio of the coefficients. So what's the limit as x approaches infinity of 4 over 2? 2. So sometimes you will get a whole value that's not infinity, not 0, that's actually just a ratio of the two coefficients. All right, let's do a couple more examples here. So number 6, what if I have the limit as x approaches infinity of 2x plus 4x cubed plus 7 over 9 plus 5x cubed? This is going to be 4/5. You're exactly right, Jackson. Because when you go to infinity, 2x, 7, and 9 don't matter as much as the x cubes. Notice here that when you have the ratio of the two coefficients, both of them have x cubed there. So x cubes are growing at the same rate. Do you guys understand that the numerator and the denominator are growing at the same rate? So I'm going to make a note here. If growing at same rate, it's the ratio of the coefficients. That makes sense? So if you're growing at the same rate, it's the ratio of the two coefficients. So you can make that note there. All right, number 7. Which one's growing faster, numerator or denominator? Look at the powers. Which one's growing faster? Notice this time you're approaching negative infinity, right? So I have 2x cubed over what? 3x squared. If you simplify the exponents, this gives you the limit as x goes to what? Negative infinity of 2x over 3. Is that right? So where is this going? Plus negative infinity. Do you guys see why it's going to negative infinity? Because it is going to a negative infinity. Double of negative infinity is negative infinity. Divided by 3 is still negative infinity. Okay, last one for this example. Notice you have a square root this time, correct? But again, where are you going? Negative infinity, right? So I want you to think about this. 100x and 525 don't really matter as you're going where? To negative infinity. So now you're going to simplify this to be the limit as x approaches negative infinity of 16x over the square root of 16x squared. You guys see that?
Yes.
Now, can you take the square root of 16x squared?
Yes.
Yeah, what is that? So the limit as x approaches negative infinity of 16x over 4x means that they're actually growing at the same rate. So what is this going to evaluate to be? 4. Limits to infinity.
What do you mean? Tell me why.
All right.
Operator.
All of this has kind of alluded to, listen, all of this is kind of alluded to horizontal asymptote. Have you noticed we've got one of 3 answers every time we've done this? Either we've gotten infinity, we've gotten 0, or we've gotten a ratio of the coefficients. Those literally are underlying ideas behind what the horizontal asymptote is back from Math 3 and pre-calculus. Do you guys remember the 3 cases of horizontal asymptotes? I think we very briefly mentioned this because I knew we were going to really do it again now. Okay? So notice here that the limits are not approaching a specific value C, like vertical asymptotes. Vertical asymptotes, the limit has to approach a finite number. Okay? And then that limit evaluates to infinity or negative. This time with horizontal, it switches. Notice that the limits are approaching what? Infinity or negative infinity, and they equal a finite number. Does that make sense? So they equal a finite number. So then, if the limits approach infinity, it's a horizontal asymptote. If the limits approach a value that's finite, it's generally going to be listed as a vertical asymptote. Excuse me. So that's the biggest way to tell the difference. I know this can be kind of confusing at the start, but you've got to look at what your limit's approaching. In the case of a horizontal asymptote, your limit is approaching negative infinity or positive. With a vertical, it's approaching a finite number. Does that distinction make a difference? Like, do you guys understand that big difference? So vertical asymptotes evaluate to infinity. Horizontal evaluate to a specific value. All right? All right, we're going to find the horizontal asymptote of each of these, starting with number 1. So what is going to be the horizontal asymptote here? Okay? Remember that this is when you do a degree comparison. Before this, you would look at which had the higher degree and you would make your decision. But remember that it's a limit as x approaches what? Infinity. So you're going to use the same techniques you just used to tell me what the horizontal asymptote here is going to be, if it exists. So here, which is growing faster, the numerator or the denominator? So notice the 8 doesn't matter, so it simplifies to 2x squared over x cubed, which then evaluates to be x approaches infinity. If you simplify these exponents, you get 2 over x, correct? So what's growing faster, numerator or denominator? So what does this limit approach?
0.
0. Therefore, y equals 0 is the horizontal asymptote.
So would they give this to us and then tell us to like
Find the horizontal asymptote. Yep. You do just this.
On like our test, do we need to write out each step or if we like know the rules?
Do you know the rules? Generally, there's going to be multiple choice type of questions.
So like if we don't write out that work, we're not going to lose points. Okay.
I'm thinking about how I'm going to assess you on this test, and I'm not going to be asking you much about this in terms of free response. There's other things I want you to show via free response. This is going to be more multiple choicey type of questions.
we have to memorize like
You need it. Well, I mean, it's not really memorizing. If x approaches a number and the limit's infinity, it's vertical. If it approaches infinity and it equals a number, it's a horizontal. Like, it's just what x is approaching. So here, what's x approaching? Negative what? Probably going to be a horizontal asymptote, right? So tell me what it's going to be. None, 0, or ratio. So take a look at the powers.
Ratio. No, none.
This is probably going to be none because here, let's take a look. Mark out everything that's not the highest power, right? On the numerator denominator. So notice here, as I approach negative infinity, I'm looking at negative 4x cubed over negative 2x squared. So then, if I were to simplify this one more time, negative 4 over negative 2 is positive 2 over what? Oh, it's over 1, but it'd be 2x over 1, right? Is that correct? So I have a question. If I double negative infinity, do I have a finite value?
No.
No, you don't know where that horizontal asymptote is going to be, so guess what? Well, this actually goes to technically negative infinity. Therefore, no horizontal asymptote exists. Because where would you put that horizontal asymptote? Anybody have an idea?
Really far down.
Or really?
Or,
Well, no, it's not really far up because it's going to negative infinity. So how far down? Infinitely. Yeah, okay. Well, that's not a finite value. All right. Last example of the day. Can you write each of these as a horizontal asymptote? Can you write each of these as a horizontal asymptote? No, you're writing the limit. I told you what the vertical asymptote, excuse me, the horizontal asymptote is. I told you what the horizontal asymptote is. I want you to write me the limit representation of that. So what is going to be the limit representation of number 1? So I know that the horizontal asymptote is y equals 0. I know that x is approaching infinity, correct? So then I know that my limit as x approaches infinity of f of x will equal what? 0. I don't know what the function looks like. The only thing I know is that the function as x approaches infinity is going to be 0. Jason, you gave me a potential function. 1 over x is a potential function where this is true, right? But is that the only function?
No.
No. I mean, you could tell me that it's what? Negative 2x to the second over 6x to the fourth, right? Like, those are multiple representations. However, you don't know what the function is. We don't know anything about f of x. The only thing we do know is that as x goes to infinity, the limit of that of f of x is going to be 0. What about this one? You know the horizontal asymptote is going to be negative 3, right? So what do you know is true about the limit? That the limit as x approaches infinity of f of x, g of x, q of x for Jason, j of x is what? That's it. That is how you write them.
Why do we, what skill is that you need for just doing that?
Translating.
Okay.
You need to be able to translate when someone gives you a limit about what that is. Limits to infinity are either horizontal or vertical asymptotes. That's the idea today. We're going to start curve sketching in our applications unit in unit 4 of derivatives. And these ideas are going to be very helpful there, okay? But not in isolation. All right? Yes. We are done with notes, and I'm now pausing. Yes, I will go back.